Hey, I'm Bill Simpson, and I'm going to tell you about air pollution. And I don't really have to tell you about that because I think everybody here in Fairbanks knows that we have bad air when there are conditions like you see here. These are conditions where there's a temperature inversion. So there's warm air overlying a cold pool of air that fills the valley. And when that cold pool of air is down in the valley here, things that we emit at the ground surface stay down at the ground surface. So the pollution builds. So what you can see here are some plumes that are trapped down low by this inversion. So the reason we're concerned with this is that when you breathe fine particulate pollution, or PM 2.5, it causes bad health effects. So you can see in this 6 city study a set of cities, and you can see there is a relationship between the fine particulate pollution, or PM 2.5, and adverse health effects. So the cleaner the air you breathe, the better your health. And that's why we're concerned with this problem here in Fairbanks. It's been a regulatory question in Fairbanks for quite a while. We've been violating the Clean Air Act for years, but there were a lot of questions around the community that weren't being addressed because they weren't really regulatory questions. So as we did this work, we often heard questions from the community like are listed here. For instance, how high does the pollution get on strong inversion days? Are the regulations working to clean up the air? And what am I breathing inside my house? I'm inside a lot when it's really cold. So what's it like inside my house? So we set out to answer these questions, and we did a study last winter, which brought in there's about 100 researchers total involved. About 48 people came here to Fairbanks to do this air quality study from 20 institutions. And I'm just going to give you a few preliminary results. So first off, the question of how thick the polluted air is matters because if you have a thin polluted layer like here, you have a concentrated pollution. While if it's a less inverted day and the polluted layer is taller, then the air is more diluted and there's a lower pollution, a lower PM 2.5 concentration. So we really want to know how thick the polluted air is. The way that we got at this is we designed an experiment where we would shine light from a parking garage in downtown Fairbanks over to Birch Hill. And then we would analyze the light that came back from mirrors placed on Birch Hill that would tell us about the amount of pollution between the source, searchlight essentially, in this parking garage and mirrors on the hill. So this is kind of the design. And here's where the mirrors are by the stars right here. And then I got to have a good day with a guy named Saul, who is from UCLA, to ski out the retroreflectors, the mirrors. So what you see as the result here are the concentrations of SO2 at the different retroreflectors. And you can see that there's a high concentration down at the lowest retroreflector, which is actually on a school in town. And there's a much lower concentration on even the second reflector, which is only partway up the hill. So you can see that the pollution is trapped really down low, and it really agrees with where you can see the plumes getting up to. So we analyze these data, and what we find is that during these strong inversions, the pollution only gets to be about 100 or 200 feet above the ground, which is not a very high height. So there's not a lot of space for the pollution to get in. And we always need to minimize emissions, but particularly during these days, you need to minimize emissions because it can't go anywhere. So, of course, Fairbanks has been doing a lot of things to improve the air, and that's actually something that is helping out our air quality, as I'll show you. Some of the things we've been doing are things like wood stove changeout programs to replace with better wood stoves, burning dry wood, and then, of course, we have air alerts when there is a really strong inversion and the pollution can't get out of town, and you're not allowed to burn during these air alerts unless you have no other source of heat. So looking at how well this is working, we can look at the regulatory quantity, which is the 24-hour PM 2.5 concentration. And this has been coming down a lot. So if you look at the highest line, which is our violating monitor, the Hearst Road site, you can see it went from about 160 micrograms per cubic meter down to about 70. So it's come down by more than a factor of 2. It's still above the Clean Air Act limit, so still more needs to be done. But as we saw in the first slides, anything that brings down pollution is better for health outcomes. So this is good stuff. come down. If you look in downtown Fairbanks, there's less residential heating and there's a lot lower pollution levels. So you can see that the average pollution levels are here, and also in Fairbanks have come down by more than 40%. So we're cleaning up the air, and that's good for our health outcomes. One of the things that we know is in the pollution is we know that there is sulfur in the particles. And that sulfur comes from sulfur in heating oil largely. So we used to burn #2 heating oil, which is relatively high sulfur heating oil, and that essentially turns into sulfur dioxide, a gas when you burn it, or into sulfuric acid. And that sulfuric acid is shown here rotting out the flashing on this chimney. And if you look at your oil chimney, you'll probably see something like this. You might even have holes in your roof because of that sulfuric acid. So we can get rid of this by what this leads to particulate pollution in that some of that sulfuric acid condenses onto the particles. And it's something we want to do to reduce the amount of pollution out there. There's been a new law that was passed in order to reduce the sulfur in the heating oil, and that has gone from #2 heating oil to #1, which has about half the amount of sulfur in it. And you can look at the real-time response to this by looking at the SO2 concentration this winter compared to previous winters. And what you can see is the historical winter average is like here, and then in red is this winter. And you can see it's much lower. It's about half this winter compared to what it is before, which is what we'd have expected here. So what we can see is what we're doing to clean up the air is definitely working. It's cleaning up the air both in terms of particles and in terms of sulfur dioxide, which is dropping significantly in this last year. So one of the questions that people always ask is, I'm not outside all the time. I'm indoors a lot. So what am I breathing indoors? So we often heard the question, what's inside the air in my house and how much outdoor pollution gets inside? And then what about things I do inside, like cooking or heating or something like that? So what we did is we rented a house in the Hamilton Acres neighborhood, and then we filled the garage with a couple $1 million of equipment, which can then measure particles outside. So we had sampling inlets here out through the garage door, and then we had another inlet back behind where this photo was taken, where we sampled air from the house. So we could compare indoor and outdoor air. What you can see is that the air outside right here, this full length of the bar is the air outside, is reduced significantly inside the house. So inside the house, it's right here. It's about 1/5 or 20% of the particles inside the house compared to outside the house, which is good. The house is protecting. This, of course, varies depending on how tight your house is and a lot of other things. So this is a result from one house, not all houses. You can also clean up the air inside with air purifiers and things like that. This is when we didn't do anything in the house. If we did things in the house, like cook food or burn a pellet stove, which turned out to have a leaky chimney, we found that you got a lot more particles inside the house. So now the particles inside the house, this bar right here, is larger than the outside concentration of particles. So you need to be careful about that protective skin of your house, that it also keeps things inside your house that you emit inside. Of course, we know that when you're cooking things, you make particles which often are food particles, and maybe aren't quite as toxic as things like wood pellet smoke. So what we did is we analyzed the toxicity of the particles by taking them onto a filter and then putting them into a fluid which kind of mimics the fluids inside your lungs to figure out the toxicity. And what we found is that the cooking particles, as you would probably expect, were less toxic. The scale here is showing the color hue as the amount of toxicity, while the pellet stove particles were actually more toxic than outside air. So overall, this is a big study. A lot of results are coming out of this study. So I've only shown you a couple of quick results from this, but we're writing papers and there's going to be lots more outreach events. This is a picture of the team towards the end of the study, and then these are the institutions who are involved. You can find out more about this by going to our website, which is the Fairbanks Winter Air Study, or fairair.community.uf.edu, and I'd love to take any questions you guys have.